When you first open FoCuS Point software, you will be presented with the following screen, with areas for plotting and for data management. To get started, we need to import and correlate some data, and we do this by clicking the Open File button. Now we select one or more files to import and correlate. We're going to select 3 this time. And we can see the progress of the correlation down here. And we'll start to see the intensity time traces appear here one by one, and each file appearing in the data management section down here. Once imported, we can see all of the correlation functions displayed here. The autocorrelation of channel 0 in the top, the autocorrelation of channel 1 in the middle, and the cross-correlation of these two channels displayed in the third window here. We can at this point export the data in a correlated CSV format for subsequent analysis in this software or in other software, or we can process the data in a slightly different way. Now, because we are collecting single photon data, we're able to view the arrival times of the photons subsequent to every excitatory pulse, shown here in the photon decay curve. And by clicking and applying time gates to this distribution, we're able to recorrelate the data using only those photons within our desired time gates. So we can do more than one of these, and up here we'll see that these particular time gates appear, and we can then apply them to our original data. So we can either apply it to individual data files, or we can apply it to all of those that are already been imported. So that's what we'll do this time, and then we'll click Create. And now it will re-import each of these data, but will only correlate those photons in between, in this case, the blue time gate displayed here. Now you can see we have 6 imported files, the originals and the time gated ones. So through this functionality, we're able to apply filtering to our imported data. Now, once the data is correlated in the way that we want, we can then go to the Fit Function tab and apply specific models to our data. So if we check our data here, we can see that each of the imported data in each channel and the cross-correlation is also available. So we can plot them all, or we can plot individual ones. So for now, we're just going to fit one data point. So we uncheck everything and just go for this one here. And you can see here we have a nice correlation curve, and we also have the customary after pulsing artifact, which you often have with single photon counted data. So what we're going to do is we're going to apply a fitter model to this so that we can estimate our diffusion parameters. Because of the after pulsing artifact, we only want to fit this region of the curve here. So first we move the limits of our fit, represented by these vertical grey bars. We can do that through the drop down box or through pulling the limits like this. And then from our available data, we can choose to fit this particular data, or we can just highlight it here and say fit with parameters rather than current, which is this list. We can do only highlighted, and then we should see our data being fit. And you can see the first time it hasn't worked so well, but if we reiterate on the parameters that we've found, we can see we get a perfect fit. Now once we fit one data, we can very easily, using these parameters of this curve as initialization, we can then fit all the remaining curves. So we do this by doing all, and you can see that now it has fit all of the raw data perfectly, represented by the green, and some of the time-gated curves not very well, based on this chi-squared cutoff value, and the remainder very well. So through changing the limits and also the parameters of the curve, you can get better fits. But for now, in this tutorial, we'll continue with this data alone. So if we highlight our original data, we can then view the parameters here, the transit time, the alpha, the offset of the curve, or we can export all of this data to Excel. So one way of doing that is to directly copy the parameters, which is done by clicking this button here, which will copy it to the clipboard, or we can take the raw plot data and the plot data of the model, and we could potentially fit it in another software, or rather than copying it to the clipboard, we can save out both the parameters and the plot data to an Excel spreadsheet, which will have the name defined here and will be located in this folder here. So once we've fit our data and we've exported it, we can also visualize the data in different ways. For example, we can have a little look at a scatter plot comparing, say, the transit time with the offset. And we can copy this data, for example, to the clipboard or save it to a file. So focus point by default fits a 2D diffusion equation, but there are many alternative equations with triplets and different numbers of diffusion species and number of triplets. So this is the basic functionality of focus point, and by checking the manual you can find out what more of these functions do.